Hi everybody, welcome to this month's edition of Civil Engineering Today. I'm your host, Reed Brockman, and today I have with me Eric Nelson. And Eric is from Structures Workshop, and that's down in Rhode Island, and he also teaches at MIT, teaches structural engineering at MIT and at the Rhode Island School of Design. And he's been creating something called the Structural Engineers Manifesto over time, written in some structural publications in Structures Magazine.
Yep.
And welcome to the show. So,
thank you for having me.
So the first question so your real job, I know you do a lot of writing, and I love your writing. First, I want to tell you.
I appreciate it.
And it really, really puts a bright spot in the day. Like, most people don't get into reading like a structural publication when it comes out, but
right, yeah.
It's just like, it's a real bright spot. And I just want to ask about your real job, Structures Workshop.
Sure. We started 4.5 years ago. I worked for larger consulting firms, structural engineering consulting firms in New York City prior to that, and in Rhode Island, and decided to start my own firm. We grew. We're 3 people now. We do a lot of projects. Every year we're doing close to 100 projects a year. Small, very small to medium-sized projects. Traditional, with architects, and then we work for fabricators and contractors, but structural engineering every day, and project work every day, design basically. And then I teach, like you said, I teach a class, usually 3 hours a week. And writing is just on the side, kind of pastime, weekends when I find time, and things that I'm reading and I think it's a good idea, I try to write on this blog, and that's fairly recent, the writing aspect of what I'm doing. I just started this blog, which is a lot of fun.
Well, I'm going to tell you, the thing that really draws me to what you've written is that you can feel the inspiration in behind it, and everything you've written. You can tell that you love designing.
Right.
And I can tell in the manifesto that you're writing, it's pretty funny calling it a manifesto. It sounds so formal. It's actually very, very light and fun.
Loose thoughts on the profession, but right.
But you've done a lot of tie-ins, comparing, you've brought writers into it and other famous, pieces
Designers,
of writing that you've brought in. You even brought Robert Pirsig in, who wrote, Zen and the Art of Motorcycle Maintenance.
Yep.
And that one I thought was one of your, I'll tell you, so far, to everybody, this is a growing list. So far, it's up to 28 and probably has more as we speak. And you keep on growing on them, even beyond what was published. You publish it online. What's the website?
It's the blog off of my website, the company website. So structuresworkshop.com, and then it's the blog button there, and it's just a WordPress blog, and a portion of it is devoted to this manifesto, I called it, and it's really just thoughts on my profession and how structural engineers, and maybe engineers in general, civil engineers, but beyond that, engineers in general, can look to grow. It's just these ideas about how, I think we can improve it in our daily, activities as designers, and just some thoughts on how to go about doing that. Ideas that I've picked up over time that I think I'd like to see in myself more, and in others more, in my company, and then in our collaborators as well. So.
Right, and I think people should check them out. A lot of them, even though they, you can tell they're intended for structural engineers, they apply much deeper.
Right.
The one actually, the Robert Pirsig one that I was mentioning was the one where you're comparing, a structural and a real structural engineer. In that case, in the book, he was talking about someone doing a motorcycle repair. An intelligent person versus an idiot.
Right. Yeah. I think that one's called reduce. What was that? That's a number in the 20s. I think it's reduce. Look to reduce idiocy. So yeah, that was probably while I was reading that book, and I thought, this is kind of a perfect time to think about this, because we do run into people that are making mistakes in their work, and then they're not correcting them, and we have to reflect on our work and improve the next design, so that was kind of that blog entry, that piece of the manifesto was how do we reflect on our work and then take the next project forward, not looking backwards, but kind of actively improving our projects, our deliverables, our details, and so.
Right, you can't churn things out just once and expect it to just be there and be
Right.
done. It's you
Yeah.
gotta think, you gotta fix.
Right, and what we do is, as engineers, the built world, is going to be there probably for our lifetime. So they're going to, our details are out there, and we see them, and we see our mistakes. So we see where we've improved. We see mistakes of others and how we can improve. And
Right, that was another
so-
one of your big points, is look not just at what we do, but look at architectural history, the history
Right.
of architecture.
Yeah, I don't think as a whole, and I haven't done any historical analysis of engineers in general and et cetera, but as a whole, I don't think we prioritize reading of history enough, certainly in our curriculums. There isn't a requirement, an ABET requirement from an undergraduate civil engineering program that requires a history of structures, history of our greatest engineers, architectural history. So that's something that's lacking in our curriculum, the liberal arts side, but specific to engineering. So we're not learning about historic structures. Many engineers don't know of the greatest structural engineers alive today or in the past century. You can name them, and they Eiffel-Eades and Rice and all these different incredible engineers, and there are engineers practicing 20, 30 years still haven't
Right.
learned about them and their structures, and so we could do a better job probably
Right, we do. It seems like
of adding that.
when I'm working with schools, when I'm working, I'm usually working not with college students, but more with kids K through 12, and I bring them on tours of Boston bridges, and when I'm
Oh, that's
doing the
true.
tours, I'm realizing I'm telling these kids more about the history of the structures probably than
Than you
I
learned,
learned in my
sure.
entire college
Yeah.
experience.
Yeah, the priorities the priorities in the university are really science and math curriculum. So the engineering in university is engineering sciences. It's really a mathematical. You feel like you're a math major or a science major when you don't really learn about architecture, history, or art, and there is an overemphasis on that. In our curriculum, we have in my opinion, we overemphasize the importance and we underemphasize the importance of other pieces. So, we require, for example, 3 semesters of calculus, and then
Right.
how many practicing engineers?
For some forms of engineering,
Right.
it seems important, but sometimes in structural engineering, I'm wondering why.
Yeah,
that goes so
and
far.
the unfortunate thing about that is that we lose some people. We have a 50% retention rate in our universities. It's pretty poor, and part of that is, I think students are in that curriculum and they feel like, oh, this is what engineering is. Engineering is science and math, and we know as practicing engineers, it's much bigger than that. And so, there are things I've written about. What is engineering exactly?
Yeah, that's actually your number one point. You went through like
Yeah.
a whole bunch of good and
Yeah.
bad definitions put out by different groups.
Yeah, because the current thinking is pretty one-dimensional. I think a lot of people, and younger people especially, and people new to the profession, so right out of school or in the engineering programs, think that we're applied scientists. Engineering
Yeah.
is applied scientists, so big. So I understand the importance of science and math, and I was actually a physics and math undergraduate major. So I respect it, I really enjoy it, and so, but it's not engineering. It's a portion of what we do, and it has to be right, but it's not. It's actually a smaller portion of what we do than probably people think. So I tried to explain that a little bit better in some of my writings.
Yeah,
We have to think we're
as
bigger
far
than
as-
that. We're bigger than applied scientists, and so we're not, essentially.
You went as far as to say that the engineering came first. That
Right.
there was an intuitive understanding
Right.
of engineering, and
Yeah, I tried to separate this idea of like what design, and then what is the engineering science portion of it. So we've been, in history, we've been designing structures well before we've had the mechanics and the analysis and the mathematical analysis to be able to understand what we were doing. So we, prior to Euler, we were designing columns. Now we know Euler buckling today, and now we understand buckling theory and understand slenderness in columns and proportional to radius of gyration. We understand these technical terms, but builders of the past have been designing columns for a long time. The catenary in Bernoulli and Euler, we've been designing catenary arch structures for a long time. They might not have been a perfect catenary, hanging chain, but we've been designing cathedrals and arch structures and semicircular arches and parabolic.
Rope bridges must have come first.
So what was that then? And the point was, well, we were doing engineering prior to the science came, and sometimes the engineering informed the science. So I reversed the idea that engineering is applied science, and I said in one of the entries was scientists are applied engineers, because they in some ways that came after what we do, and it's still coming today in sciences. We're designing structures for a lot of things we don't fully understand. We don't fully understand soils, and we don't fully understand material decay and aging of concrete and masonry. And we're still designing these things. So the science might not have seismic events. Obviously, we have to interpret very complex phenomena and create a building. And so we have to interpret those codes and make decisions, and it's not always based on science. It's based on a lot of uncertainty.
Yeah, and with that uncertainty, that was one of the things that might have been good about, the more specific we get, the more we learn, the more technical we get. People want to hone in and get rid of those safety factors that kept us safe for all those years sometimes.
Sometimes, a lot of times what you find, that's interesting, you find with new codes, and code complexity is a very large problem in our profession, in my opinion, but many practicing engineers share this, that codes are getting too large. And it's because our engineering educators are adding complexity to the codes to try to get our structures and our analysis closer to reality, to try to mimic reality a little closer so we can tighten up factors of safety. But we have to create more complex analytical models. We don't have as good of intuition about what a wind load might be, because the formulas became very, very large and time consuming.
Right. Well, they get so time consuming they end up taking a really short time, because instead of
use software,
use a piece of software, but
then you lose everything.
You lose all the
It's a black
feel.
box, and so there's a problem. There is a problem there that we're trying to. We understand it though. It's I think a lot of us are trying to push back against that. I'm actually a member of the ASCE 7, which is the load code committee, and my goal is to sort of make sure we're not adding too much complexity where it's not benefiting the project, it's not informing a decision, it's adding an unnecessary complexity to something. So well, hopefully the future is brighter, but right now we have very wide, very thick building codes, load codes, material codes, and they just get thicker, and so it's unsustainable, and it's dulling to your mind. It's not healthy. So you start to use software that's also dulling to your mind. So there's a problem there, but I think the design community understands that.
Right.
And,
you had some great solutions to it too. You were suggesting some great things. You were saying to make drawings one-to-one. You were saying build physical models. And
yes.
Several of the points tied back to that.
Yeah, I think in our office, we're only 3, but for example, one of the things we all do, I had everyone take a welding class. So we all welded. We're designing welds all the time because we do a lot of connection engineering calculations for fabricators. But we size welds, but do we understand? So also we have samples of all structural components in the office. So
that's a beautiful idea.
So we have every type of engineered lumber, wood, dimensional lumber, CMU, different types of masonry and brick, all the kind of the metal components of wood construction, concrete cylinders, steel shapes, cut shapes, angles, connection material, shear tabs, double angles, all the different types of bolts that are on the market, all the washers. So it's all there.
I
So
gotta see your office one of these days.
It doesn't take a lot of space because it's just 1 foot sections of different
Right,
things,
right.
but we can pull it out. And, for example, if we'll do a small project like a deck outside of a house, build a deck. And a decision might be, well, these columns, I'm a little concerned about the 4x4 posts that are 8 feet on center. And I think we should go to 6x6. An engineer in the office thought, and I could just pull them out. And a 6x6 is huge.
Yeah.
So they don't have a 5x5. So it goes from 16 square inches. It's 3.5 by 3.5. But it more than doubles the area going from a 4x4 to a 6x6. So you can just feel it. You feel it in your hands and you understand, we really don't need this for that. I know what the numbers tell me, but now I have a feel. And so we feel materials. So we draw 1-to-1 scale. So we might draw a detail 1-to-1 scale so we can really see. It's just a hand sketch. That's something that I encourage in our office. Other ideas is just sketching a lot, sketching
Right.
all the time.
And not getting perfect.
Not worrying
perfection.
about, I think there's a lot of, we get intimidated by architects who send us, their sketches and they're beautiful and they're artistic. And we need sketches that are clear and useful to communicate a design intent. And we need to do them quickly and we need to scan them and send them to the architects or the contractor who we're working with. So we need to constantly sketch, hand sketch, draw with a pen. So these are all ideas that I think we can.
Maybe we should just take a second and give a little background. It's funny because you teach both structural engineers and architects at two different schools, at two great schools. But not a lot of people know the difference between an architect and a structural engineer. It runs very much hand in hand. They're almost like a team. Sometimes they're fighting with each other.
Right.
What is the primary difference between
That's a great question. And to be honest, I don't know because I know, I think I thought about this a long time, and engineers tend to, a lot of times we've decided our profession during undergraduate, and we tend to do better in subjects, calculus and physics than architects do, and they might get discouraged. But there are some architects that we work with that I know they would be terrific structural engineers.
I agree.
And I know structural engineers that would be terrific architects. And there are architects that couldn't be structural engineers. So there's a wider range of abilities, and so you can't really compare the structural engineering community to the architecture, because it's like comparing to almost the architecture community is so wide and varied. They have a lot of different skill sets.
Right.
So there are very technical architects that work in departments that do a lot of waterproofing detailing.
Right.
And then there are architects that work on exterior facade renderings. And these are different things, and
at
they're
the
both
same-
equally important. And so where do structural engineers fit in there? It's tough, but one of the differences in the undergraduate level is we tend to excel in the sciences and math, and we have an easier time with it. And so we didn't drop out of engineering, but there are a lot of similarities between architects and engineers in growing up, and a lot of structural engineers, I think, could have easily become architects. And they just decided to choose structural engineering because they liked the physics. They actually liked the science and the math, and they were comfortable with it, and they actually liked this idea of designing structures for forces and things.
So you think they both stem from the groups that loved Legos?
Yeah, they both build Lego. Yeah, they're both exactly builders as well. But there are differences, and so it's hard to pinpoint. It's difficult, but there are a lot more similarities than there are differences.
I'm thinking that too. I think one of the things is maybe that like a good structural engineer has a strong sense of architecture, and a good architect has a strong sense of structural engineering, because they're so hand in hand with each other. It's hard to pick it apart, and people like to say, these statements that that would sound good on paper, but they like to say, that architects are artists and that structural engineers are the mathematicians. And that just doesn't work at all in my life's experience.
Right. I think I've worked with teams of architects where within the same firm you have an architect that has no understanding of structural engineering, and that's okay, because their role in that team is a different role than maybe the project manager of that architecture firm, who's questioning our structural details or asking or coming up with solutions or ideas of structural systems. So an architect can have a role with different levels of structural understanding, completely different. But engineers, we do have to understand, architects, because those are our main client, and especially in the building industry.
Right.
So we do have to understand what they're thinking, what they want in a particular situation, and so you do have to understand where they're coming from and their backgrounds.
Right. I think we have the same thing. I think that there's in the world of structural engineering, you could be very much into the specifications and thinking about the leakage problems and though it's technical, it's not numerical.
Right.
Meanwhile, there's people who just love finite element analyses and really getting deep into the theoretical. So we kind of have the same thing.
We do. Yeah.
There's one point that I want to come that you talked about that I just thought was beautiful. It was where you were talking in one of your points about you were talking with the contractor who was talking about he fabricated what you had designed. And he was really proud of it. Do you want to tell about?
Yeah, we designed a large box truss, a steel truss that was 1 story deep, and it was 10 feet wide, so 2 trusses that are parallel, and he was very proud of when it was built. I was inspecting the project and made sure that it kind of conformed to our requirements and our calculations, and we designed all the connections, and he was very proud to show me all of his welds. And the comment in the blog was he knew that was all going to be covered up by the architect.
Right.
But he wanted to show me his effort and his skill and his ability to create a quality truss. In the same way we think of ourselves in designing connections that are very efficient and economical and simple to build. And so I talked about how that was more of a manifestation of himself. He was thinking of himself as a good person, and he wasn't just showing me the craftsmanship of the weld. He was describing how he was actually a good person. So it led into that idea of ethics and humility, and that was one of the entries, I think.
And I think that's really beautiful, and we're running out of time.
Yeah.
So I know that time flies by, but I think that was part of the beauty of it. Is that's what hit me about your writing was really the personal feel, and I think it's beautiful what you're doing, and keep it up and keep them coming.
I will.
And everybody,
it's fun.
check out, what's the website one more time?
It's structuresworkshop.com, and you'll see the blog. You can just click on that.
Great. So everybody, students that are out there that want to participate in the Model Bridge Contest, go to www.engineeryourfuture.org, and you can still get involved. The Future City deadline's come and gone for registration. Anybody wishing to check out anything that we're doing, check out www.engineeryourfuture.org. And Eric, thank you very much. And everybody, I'll see you at the next month's show. Thank you.
Thank you.